last class, if you guys remember, we started week 4. This is technically week 4. So we took that through expansion valves. That's where we left off. We're going through our refrigeration cycle. Our refrigeration cycle is now bringing us, after expansion valves, we went through distributors. Our next piece is the evaporator, right? This is our 4th component of our refrigeration cycle. Okay, so we're going to talk about in refrigeration what's different. You know, what does that look like? What's the practical piece to this? So the first thing I want to talk about is fins per inch. Most of us have some type of background in air conditioning. And the most obvious thing that we'll see when we move to refrigeration is the fins per inch. Way less fins per inch. So what's going on here? What's a fin per inch? What are we doing? All right. So the purpose of our evaporator is boiling the refrigerant, right? We want to exchange heat in the space. This is the point to the whole system. If you know whatever space we're trying to cool is why we're doing this whole thing, right? It's what it's all about. This is where the rubber meets the road. So to do that, we want this heat exchanger, and that's what an evaporator is a heat exchanger. It's exchanging heat from 2 different mediums, right? We want that to be large. We want it to be big so it can exchange a lot of heat. The challenge to that is it's wasted space. I can't sell product where I have this heat exchanger. It physically takes up space. So I want to be able to exchange that heat with a giant heat exchanger, but practically I need it to be small so it fits into a small space. Okay? So the way that I make the surface area of my heat exchanger bigger than just the copper tubes is I mount aluminum plates to it. I can use any conductive material. It doesn't have to be thermally conductive, right? It doesn't have to be aluminum. We choose aluminum not because it's a really great thermal conductor, because it's cheap and light, right? Copper would be better, right? Copper things would be way better. They'd exchange heat far better, it'd be stronger, more durable, be insanely expensive, and crazy heavy, right? What about what?
Stainless is hard to work with.
So stainless is not a really massively great thermal conductor. It's not bad, but it's not spectacular. So you don't really gain a lot of thermal conductivity there. It is better than aluminum. So anyway, so what we're doing with the aluminum fins is we're attaching them to my actual tube that my refrigerator is boiling in and absorbing heat, and we're using that to make that surface area larger. That's the point, okay? So that means the more fins per inch that I have, the more surface area that coil has. Got more of those pieces of metal, making it larger, right? In the same physical size, right? So that means more fins per inch I have, the better. So why don't I pack this thing full? Right? Why do I have less fins per inch in refrigeration than I do in air conditioning?
Because you need to allow room for ice buildup.
Nailed it. All right. Every evaporator we have, with the exception of maybe the meat prep, is running below freezing. Right? The saturated temperature of that coil is below 32 degrees. Right? If I got a 32 degree case, I got a 10 degree TD, I got a 22 degree evaporator coil. That's below freezing. So instead of it sweating and creating condensation like an air conditioner, it's creating frost. Right? So I've got to have more fins per inch to allow room for that frost. If I have, like on this left picture, if I have frost on this fin and I have frost on this fin, I must have a gap big enough for air to also flow. When the frost touches and I stop my airflow, that is what we call an iced up coil, and that's a service call. My case is running warm because I'm not moving any air, right? So the tighter the fins per inch I get, the less room for that frost I have. All right? So this is a balance. It's a very, very delicate balance for refrigeration, extremely delicate. I'm gonna engineer this case, and of course I'm not, right? Someone is gonna engineer this case, and they're going to expect some air to spill out of this case onto the sales floor. Well, just like an air conditioner, if I'm blowing a duct into the attic, right? That return is gonna suck that air in from somewhere, right? Well, that's what's gonna happen here. I'm blowing it out into the sales floor, then something, that air has got to be made up. I have the same volume of air has gotta come from somewhere and go back into the case. It's gonna come from the sales floor, right? So when I blow air out onto the sales floor, I'm gonna suck air into the case from the sales floor, right? That makes the humidity level, how much water is in the air on the sales floor, critical to this problem. Critical, not like kinda, no, really, right? If I have more water in that air coming into the case than it can handle, I'm gonna grow the frost faster, right? If I grow the frost faster, I'm also gonna engineer this case to have a defrost that is just enough, not too much, not excess, right? Because that's wasted energy and my product is getting warmer every time I defrost, right? I'm not refrigerating my product, and if it's electric defrost or hot gas, I'm doing work that is not cooling product, it's warming product. Yes, sir?
Wouldn't I guess, further the importance of the dew point in the store, wouldn't there be even more moisture attracted to the case because it's colder than the store?
Yes.
On top of it pulling return air?
Right.
Like you're
Right.
gonna get a little bit in there.
All right, so the point he's making is a principle thermodynamics, and that is my water vapor is always gonna go to the coldest spot. Just is, right?
Even on like glass doors, like it's
Yeah.
closed and it's sealed.
So why does it ice up?
Sealed tight.
Yeah, why do we still have ice in it, right? Why is there no ice? Why is it not dried that out, brought that humidity level to 0, right? Why does that continue? Yeah, exactly. Every time somebody opens the door, whether I'm spilling air and actively forcing that wet air into the store or not, that definitely speeds this up tremendously, right? But even if I didn't do that at all, water vapor would penetrate that air wall, right? Because water vapor is a vapor. It's not a temperature of air that we're moving, like cold air and hot air. It's like spraying perfume in a room. It's gonna mitigate, evenly disperse amongst the space. Well, that includes my case, so it's coming into the case. I'm absolutely gonna pull some moisture through that air curtain, through that air wall, yes. To answer your question, yes. Spilling air greatly increases that process, but it's gonna happen anyway. You're absolutely right. So my engineers are gonna calculate all that. And when they tell me that my space must be at 75 degrees, 55% humidity, that's the standard for all case manufacturers, right? 75, 55. When they say that, all right, what they're saying is if I exceed that amount of water in the air, the defrost period that they've given me will not be adequate, right? I'm going to grow that frost faster than my defrost cycle will clear. And when I go through a defrost cycle, instead of leaving a clean coil with no frost, I'm gonna leave a coil that has a little bit of frost, which means the next defrost, it's gonna add to that frost, and I'm gonna add on the next, I'm gonna add on the next until it touches and ices up. All right, we call that losing the defrost battle. That means when I'm not clearing the coil after defrost because either my defrost isn't working or I'm pulling in more moisture than it can handle, right? I could be doing that because the coil's too cold, could be doing that because of airflow, all right? That's how that balance works, okay? So when we look at the coil on the right and we look at the coil on the left, we see there's 6 fins per inch on the right, there's 4 fins per inch on the left. What can we surmise about these cases based on that? Anybody know?
One's older than the other?
One's
Older than the other?
not older, I like that. You're thinking energy efficiency, right? And that is driving some of this, but these two are generic examples, okay?
Go, Julian, go, please.
The coil on the right is gonna have more defrost.
All right, so the coil on the right, if they run the same temperature, I will require more defrost on the coil on the right. All right? What's another possible scenario here?
Brandon,
I would say the bigger ones are geared more for low temp and closer ones are more for medium.
All right, so if I'm running this thing at minus 25 degrees, right, which I do, that's a minus 15 degree bunker, for instance, it's gonna grow ice much faster than my coil that I'm running at 22 degrees, right? So yeah, between defrost cycles, I'm gonna have more ice. So my frozen, the lower the temperature goes, the more space between the coils I gotta have, right? Okay, now, the other thing we beat around first is high efficiency. Let's talk about that for a minute. The government is mandating to our case manufacturers that these cases use less and less energy every year, right? Agree with that or not, it's law, okay? So that means they don't have a choice, right? It's law. They have to sell a case that is more energy efficient than the one that they used to sell. How are they doing that? How are they getting a case that does the exact same amount of work BTU wise and make it more efficient, right? So they're just like cars, they're gonna squeeze every little bit out of every place they can, right? That's why now cases come with anti-sweat heaters that pulse. Well, the case manufacturers now can get credit for that and apply that towards this. That's why we've got those little things in there pulsing now, right? One of the ways they do it, LED lights instead of fluorescent bulbs, okay? This stuff's pretty easy, okay? But when it comes to refrigeration, there's not a lot we can do. We can use electronic valves. They are definitely more efficient. Minute amount, right? A very small amount, 0.3%, 0.3.5, something like that, right? So it's not a huge change, okay? But it is a change, and that's what they gotta get, is every one. Well, the other thing that they're doing, they're adding more fins per inch, okay? When we see the HE, high efficiency, in a model number, what that means is it's the same case they've been selling, but they've added more fins per inch to that coil. That's what it means, right? So when you see that HE and you open this up, expect you're gonna see 8 fins per inch on your medium temp. You're gonna see 6 on your low, right? What does that mean? That means gotta have more defrost, right? So if I see HE, there's a couple things that should be clicking in my head. One, my fins are tight, which means my air spillage is gonna be massively amplified. The dew point in the store is gonna be beyond critical, right? And I'm gonna see an increased number of defrosts, right? It's not gonna be 4 a day for medium temp. It's gonna be 8, 6, 8, 12, right? Are the numbers that we're actually seeing, okay? So just be aware of that. That's what this is all about, all right? Okay, anybody have any questions about my evaporator coil fins per inch?
So obviously, DOE and all the engineers for all these manufacturers, et cetera, on the engineering. But have you ever seen the numbers or know the numbers on what kind of efficiency we're actually gaining? Because in my feeble little brain, if we're turning the case off, defrosting 12 times a day,
Right,
and then turning it back on, we're increasing the load on our compressor or on our rack.
right.
To bring on another compressor increases amp draw, there's the cost of efficiency there.
Yep.
Is it really increasing our efficiency,
Right.
or is it literally moving
Right.
moving the shower?
Okay, all right, so Ian's trying to look behind the curtain. Don't look behind the curtain, Ian.
That's usually all I do.
There's a lizard back there, and it's just a guy playing an organ, all right?
Mandated.
All right, so I don't know if you guys caught what he just said, right? So he's talking about the entire system. Is it more efficient to have an HE case, a whole lineup of HE cases, a whole store full of HE cases? If I look at the power bill of this store, does the total power bill go down?
Yes.
Or do I lose that efficiency
I'm gonna tell you why.
because I start compressors up, right? And I've got inrush current because I'm changing loads, because I'm running 6 defrosts a day or 12, right?
Inverters.
So, right, it's not an invalid point, okay? If I drop these cases into, you guys remember 705, right? Compound cooling rack, 1989, right? Or 91 or whatever it was, right? Old style rack with no digital unloader. Got compound compressors, can't even have that, right? I've got the VFDs and bypass because we're south of I-10, so it really doesn't even help, right, on the condenser. So my rack doesn't change in any way, but I'm adding this.
Right.
Yeah. Am I gonna lose some efficiency on that? So that's gonna come down to scheduling my defrost. All right, if you guys remember, one of the things I said that's critical when we're talking about compressors is maintaining my suction load, so I don't have to change, right? That means if I go to 6 or 12, I better do most of the rack. If I do just a few cases, I'm gonna change my defrost dramatically. If I do the whole rack, then I can still have 2 cases going into defrost all the time. They just go in shorter and more often. But I keep my load fairly stable. So to answer your question, it totally depends on the setup. If I just change the meat cases, I probably am gonna have a reduction in energy on the rack, right? Versus the case. If I do the whole store and I balance all that, I'll be all right. But if I'm adding digital unloaders,
Now we're doing some good stuff.
now we're doing something. Because now I can even cycle these compressors on and off. I'm not actually turning on and off compressors. I'm just loading and unloading.
So, at what point do, at what point, on like a low-temp compound cooler rack, would we start looking into like a vapor injection or something, because we can't do unloaders? The rack is 3 times the size of those cases now.
Yep.
And yes, they staged the suction group accordingly and
Right.
figured it out, but at what point do we say, hey, for increased efficiency and this $10,000, we can install this and do that? Like, are we there yet or not really?
Not really.
Okay, because I know the unloader is essentially doing that for you, it's stabilizing that suction pressure in smaller increments, but on a low-temp compound cooler, which is 80% of our low-temp racks out there, how do we do that? We just don't.
We just don't.
Okay.
Yep, that is a downside for compound cooling.
Okay.
Right, that is one of the downsides. Hey, Corey, I know you were gonna answer that question. Go ahead with your thoughts.
You pretty much hit it. It would depend on, you can't leave the rack the same and expect a lower energy efficiency. I mean, you gotta get into engineering with that as far as downsizing compressors or schedule changes and all that mess.
So is there like a process that like we're potentially like gonna have to go through when we do like these whole change outs in these full new stores? So, like in terms of like whether that be calling digital assets to like have them reset the staging or like just adding the unloaders like Ian said or something?
Yeah.
Or
So the customer is responsible for what they want to do, all right? We can offer ideas all day long. As far as it not working the way they expect, now that is something we can work on, right? So to answer your question, offer to add an unloader because you think it's necessary? Yeah, you can offer that, but they may shoot that down. They've got engineering that should have told them that. Why didn't it? Okay? What's different than what they think they have? That's what we've got to identify. Versus, they dicked up the staging and it's just wrong, right? They didn't intend to do that. That's a problem, okay? So that is definitely something we will call digital assets and do all the things that I told you about. You know, verify your compressors first. Make sure they all work. Make sure their valves are proper. Make sure my rack controller has control and is bringing on the things that it thinks that it is. We didn't move a point and forget to change program, right? All those things. Once we have all that right, and none of our EPRs are cycling in the store, we're not hitting cut in, cut out, right? They won't restage a rack if that's happening. If you're hitting cut in, cut out, and you're like, well, of course your load's changing, your staging's gonna be all screwed up. That's not supposed to happen, right? You get all that ironed out, and we still have staging problems, then we can restage a rack, okay? It's not possible to restage a rack with varying suction load. So let's talk about airflow in a refrigerated case. You know, in my air conditioning system, for my residential guys, ductwork can be one of the biggest challenges. You know, what's going on with my airflow can be one of the biggest problems, all right? For refrigeration, it's a lot simpler, but it's also a lot more critical, all right? And the reason why is really because I have such a small system as far as my evaporator and the amount of heat that I'm trying to exchange. You know, we've looked at some of these numbers. Some of these are fractional of a ton of BTUs, right? Which means I don't have much room for error. That's what that means, right? If I got a 5-ton system and I'm losing 100 CFM, it's probably not gonna be the end of the world, nobody really cares. If I lose 100 CFM out of a refrigerated case, yeah, I'm gonna be throwing meat away. You know, it is the difference between it working and not working, okay? Now, the good news is, like I said, it's real simple. There's not a whole lot that can go wrong here. If it does, it is our job to figure it out. We as technicians tend to forget that our refrigeration system actually has two parts. We get so concentrated on superheat, suction pressure, right? Solid, column, liquid, all those things, which we have to have for our refrigeration cycle to work properly, right? Sometimes we forget that it's a heat exchanger, and the other part of the equation is how much heat are we exchanging, right? My airflow is the other half. It's the part bringing the heat. This is my basic open air case, right? It shows a very simple path of airflow, okay? This is way oversimplified. We'll get into, you know, some of the more complexities of this. But the concept I wanted to show here is my load limit, all right? Every case has a load limit, every one. Not necessarily marked very well, right? And the stores are famous for peeling off the load limit so they don't have to follow it, right? If the sticker's not there, then I can do whatever I want. I didn't know, right? All right, so when we're trying to determine what the load limit is on a case, we're looking for the inside of this air curtain. So this is my return down here, this is my supply up here. My load limit cannot infringe on that line. Cannot break that line, all right? If I break that line, and this is what I try to explain to store managers, that's my door to my refrigerator at home. If I go home and I open my door 4 inches and leave it that way, are we good?
No.
Yeah, right, I'm gonna lose everything in my refrigerator, of course, right? Same thing applies here. If I break my load limit with 4 inches worth of something, I'm opening the door to my case, right? It's the same thing. Why? Because we can see this air coming down. If that air gets pushed out, it's going to the sales floor. Well, I told you it's gonna make this air up. I can't have a negative pressure inside this case. It's gonna balance. So it's gonna pull my air right off the sales floor, right up the front of this case, and right into my return, right? So I'm gonna be pulling in my 75 degree, 55% humidity if I have the perfect building envelope, right? Which I probably don't. Okay, so when that happens, I don't have enough BTUs in my case, right? That's what's gonna happen, right? So load limit is really, really important. The more fins per inch, the other thing that happens is less airflow, because I'm pushing against a much thicker resistance. So I'm gonna have less volume of air. That means it's really important. If I start losing some of that, I'm losing a larger percentage because I have less of it. All right? So as we go into these HE cases, this gets more and more critical. When I walk up to a 1980 case sitting in an SEG store somewhere, I can't seem to break this thing, right? Why is that? It never ices up. Nothing ever goes wrong. The coils look rough. You know, they're starting to decay. I open it up. It's got 2 fins per inch.
Yeah.
Oh my God, never ices up, never dirty. The fans are pumping sludge water because they hadn't washed it in 10 years and it just doesn't care.
Fan motors.
It's got that.
Right? They're also 32-watt fan motors instead of 4, right? You know, I mean, yeah. Right, great case. We love it, right? Insanely energy efficient. It's as energy efficient as a 1957 Chevy, right? You know, 6 miles to the gallon, 9 miles to the gallon, something like that for a family car, right? So that's what's going on, right? And we can't have that, we know that, and that's going away. So the farther we get towards the Prius, yeah, the more critical we're getting on everything working, okay? So load limits didn't matter back then, and these store managers that have been doing this for a long time, most of our managers have got some years doing this, right? Because that's why they're managers. Right? They started out stocking this stuff, ignoring that load limit entirely.
Oh, yeah.
Well, how do you think they're training their folks today?
Respect it.
It looks good. If you pack out a case and defeat the load limits, it is gorgeous,
Oh, yeah.
right? They call it blocking, right? When they overblock a case, it looks fantastic. So that's what they want to do. And if they've got just 12 more things in that box, instead of taking that partial box back, it's a lot better if I can just force it into that case.
It's all.
Okay, and if I'm expecting it to be busy, you know, I'm gonna jam, because it's not gonna be, it won't be there long, because it's gonna be busy,
Yeah,
right? I've heard all this, right?
yeah.
Meanwhile, who's paying the price? Yeah, our service tech, because we're icing this case up, and even worse than, you know, we're getting the service call because it's iced up. Their core product temperature is not good, okay? If my case is running not at alarm, but warm, that's what this will create. I'm not gonna trigger an alarm on this, right? But if this case is supposed to run 32, it's running 35, 36 degrees, right? Not enough to trigger an alarm, but my core product has got to be below 41 degrees always, right? Food safety, core product, that's probably a whole nother class. 41 degrees even in defrost, all right? If this thing's sitting here at 35, 37 degrees, my core product's probably in the mid 40s, all right? So that's my airflow, that's the general path, that's how to figure out my load limit, whether I have a sticker or not, right? If my shelves stick into the load limit, they're the wrong shelves, right? The case can never work properly, okay? All right. So let's talk about shelves for a minute. Shelves play a massive factor in how this works, all right? Now, you can see my air curtain's not a straight line after all. It's got a little wave in it, all right? This is a case where everything is working properly, all right? This is what it looks like. So what's going on with my waves? Why is this not a straight line? Well, the reason is about half of my air is not coming out of the honeycomb. About half of my air is coming out through the perforations and the holes in the back wall, okay? So that means I'm pushing air towards the front of the case. Well, my air wall, that means it's gonna push against the wall, right? It's gonna try to push it out onto the sales floor. As long as I'm pushing it evenly, I'll have a nice perfect straight line. Well, when we walk up to a case, do we see the exact same shelves from top to bottom? Hardly ever, right? Old cases, yes. New cases, now. They like a nice little, you know, they get shorter and shorter as they go, right? We see that a lot, okay? Well, that means there's no way that pressure's even. It's not gonna be, right? When my shelves start getting shorter, as we can see up here, I have less pressure. My curtain is gonna bow in, and then when I have a long shelf at the bottom, I'm gonna push that air wall out of it. So I'm gonna get, that's why I get the wave, right? Now, the way that pressure is segmented, so it's not all the same pressure, is by the shelves. So this drawing is showing the air coming down. Well, in reality, it's flowing up this back wall, right? And it's going out of these holes. And when it goes out of the holes, we kind of think of it as shooting straight out. It doesn't. It's coming up at an extreme angle, right? Comes out of that hole, it's flowing at that kind of an angle. All right? So in order for that to work and not blow that air out into the sales floor, I must hit something, a shelf, right? That air is going to smack that shelf and deflect it down. It's going to take that velocity out of it, right? And that's where I'm going to get my down angle. That's why it's showing a down angle right here. It's because this air is coming up, it's hitting that, and then it's all down from there, right? So most of that is going to be nice, gentle downflow. Okay? That means if I'm missing my shelves, if I start up a case with no shelves, my air curtain is going to be all dicked up. It is not going to be even close to right. Okay? Now, does that mean I can't go ahead and fire the case up and start dialing stuff in? Sure, you can do that. But your final EPR settings and TXV's adjustments are going to be wrong. My final case temperature EPR, right? I can't do anything on those final settings until my shelves are in place. I'm guessing on what it's going to do.
And it doesn't require product in the case to do that, it just requires the shelves.
Correct.
Like whatever components they're using
Yep.
for the product and the shelves itself, so like.
If everything is
hangers for cheese hanging up or whatever, like you want all of those hangers in there with the plastic dividers, you want the shelves, whatever they're gonna be using for that case, ideally have it in there.
Yep.
And then do your final adjustments.
If your case requires product, and I've been there, right? I've had cases that just wouldn't make temp
Typically.
until I put gallon jugs of water on all the shelves, and then they did, right? If I've got to do that, there's something wrong. Okay, my airflow's not quite right, my shelves aren't right, my building envelope's not right, I'm getting some infiltration from somewhere. There's something not right, all right? Now, usually what that something is the store has opted to buy some kind of merchandiser that the manufacturer didn't approve. That's also very common. Stores like pushers, right? You know, they want stacks of produce, bag lettuce, and they want a pusher that pushes it out when you take it, right? That's not approved, all right? He will tell you in a heartbeat, you got those in your case, can't help you, right?
A huge problem similar to that in Dixie.
Why? Because it's a different shelf than they designed for this airflow. That means my wall is not at design. Can it work? Yeah, it can work, right? If we get everything just right. And in that case, I may have to put product in that case. If I'm using, an unauthorized shelving system, I'm almost for sure gonna have to put some product in that case. Those bag pusher engineers aren't morons either, right? But they didn't figure this out to run an empty case. They figured it out to run their product, right? Whatever they're selling, okay? So just keep that in mind, right? All right, so a couple other things, so that was the big thing I wanted to talk about, is I must have the proper number of shelves. Every one of my manufacturer's books are gonna show me the proper shelves and how many, right? It'll say I can have 4, I can have 5, I can have 6. It'll tell me how many inches they can be for each of those configurations. The stores usually have no idea, right? That somebody ships them something and they're gonna try to figure out how to fit it in the case. That's what they do. So you may find you got 22-inch shelves in this case and 20-inch shelves in this case, and it's supposed to be 22s on the bottom and 20s on the top. They don't know, right? Find that, help them. Help them help you. Okay. So the other bit I want to discuss here is I've got a plenum coil set up here, all right? We're going to talk about the plenum and the coil in a minute, but just notice where that is. In order for this to work, my fan is sucking this air through this plenum and through my coil. That's my airflow. So if anything goes wrong with this deck pan situation, I'm not pulling through here anymore. I'm pulling through here.
Yep.
Okay? So my deck pans are critical.
Yep.
All right? If I take my deck pan up, my air curtain is definitely going to be disturbed. There's no way it won't. Okay? So that's really important. The other thing I want to talk about, this shows this plenum sitting on the bottom of this case. That has to be sealed. All right? If it's not, when I'm trying to suck in my air here, I'm going to blow it back out. I'm going to recirculate air here. I'm going to be short air velocity. All right? So startup guys, this is big. If I've got piping through here, which I will, right? Make sure it's not interfering with this plenum sitting flush on the bottom and sealing to this pan. My coil, so my fan is going to be mounted in this plenum. It's going to suck in and blow across this coil. And my air, as we can see here, wants to go up this back wall. That means this fitting, wherever this coil makes to this back of this case, also critical. Right? If I have a leak here, my air that I'm supposed to be pushing here is going to roll into here instead. All right? That's going to be a problem.
Yeah, we had, there was one whole thing in this case, the surface seafood. And
Yeah.
usually, like, because it's top and bottom coils,
Yep.
they would put screws in it, but somehow, I don't know, never cleaning it, but the silicone tape, like, was not sticking to the bottom. And when I would clean the case, the whole coil pushed forward probably like 4 or 5 inches.
Yep.
And we had to
4 or 5 inches.
we had to get copper as a unistrut and just kind of like get it to sit right where it stayed.
Yeah.
But
Got to make the seal, right? And this is one of those places that, as a service tech, you may have to use a little ingenuity. It probably worked on day one. Startup guys, you should be able to assemble this like the manufacturer wanted, and it should work, right? But we've seen some pretty sketchy setups that over time no longer work, and we've got to do something different to just make it work.
This is important to check after you de-ice coils too, because if you ice up bad enough, like on some of the, I know Kaiser and Hill cases, they use like those plastic clips that hold your body panel to
Yep.
your car. They'll use those to hold the fan shroud to the coil or the coil to the back wall, and that ice will break that clip, push the coil forward. So you'll have the left end 2 inches forward and the right end where it's supposed to be, and you won't even notice.
I've got something to add to
So
that
it's
with
something
zero
to
zone
keep in mind, it's
cases.
not just for the startup guys to be checking that, like after you de-ice a case or if you're having airflow issues, that's another thing to check.
Yeah, but if it's wrong, it means you have to fix it. If you
So,
don't check it, you
what I
can't
found
fix it.
out that the 1086 was 1086 has zero zone cases, and they have the hinged top. And if that top is on top of the fan shrouds, when it does ice up, it'll push up and
yeah.
you'll lose all
It'll
your.
lift and then your ice is gonna be
So it's
exponential.
extreme.
All right, so let's talk about fan motors. You know, a couple pieces to this. The engineer has spec'd how much air pressure and volume he expects to go through that coil, go through those holes, bounce off those shelves perfectly to evenly balance that air current, right? When we start re-engineering this by using whatever we got on our truck, we can seriously impact that, all right? So we want to go back with exactly the same thing. There's really not a lot of room there to change the amount of air that's flowing through there. What does that mean? That means the biggest thing, the most important piece to this is the blade. We need to match the fan blade exactly, right? If we get a fan blade that's rated to the same thing, but it has less, you know, one had 5 blades, this one has 4, but it has deeper pitch, right? We think that's gonna be the same. It's not gonna be the same, right? My pressure's gonna be different, which means I'm gonna move through that coil differently. It will move the exact same CFM in a laboratory, but in that case, it's not going to, okay? So we wanna go back with the same blade. If we have to go back with a motor, a generic motor, that's okay. It will match the amp draw of that blade and give it and deliver the same amount of air. If I change the blade, that is not true, right? That is not true at all. I can definitely push more air accidentally or less, right? So the blade will determine how many watts the motor is gonna actually burn. That's what's gonna decide that.
So the
Now-
more pitch, the more airflow?
To an extent, yeah. So what does that mean? Well, when I'm looking at my blade, when I'm looking at my motor, I may have an EBM, all right? This is becoming more and more common as part of that efficiency piece, okay? An EBM motor is gonna pulse, and it's gonna, instead of being on all the time. So it's going to be electrically far more efficient. So if I've got an EBM motor, can I go back with a regular old cam ball? Yeah, I can.
Sure can.
To get you out.
Old faithful.
Sure.
Now, here's the challenge, what size?
Well, you got,
There becomes my problem. So, if I'm running an EBM, this one says it's a 31 watt
Calculate your
EBM
horsepower.
motor. 31 watts. So if I had to buy a cannonball, would I buy a 31 watt cannonball? They can,
Oh, gosh.
sure. Right, you see the problem, right? Everybody's laughing. Of course not. All right, of course not. It's not gonna work. Watt to watt, how much energy this motor burns,
we need Ohm's law.
that's what it's rated to. That's not what it's gonna burn. It's gonna burn a fraction of this. It's not gonna burn anywhere near 31
Do we
watt.
need to get tachometers?
What's that?
Do we need to get
R
tachometers?
equals P times I.
Hopefully not. Yeah, we shouldn't need one, right? So the question is, are we gonna get tachometers? Are we gonna measure RPM?
Should.
All right,
Some
so
case specifics.
we shouldn't have to, and the reason we shouldn't have to is because we're gonna go back with the OEM motor. All right, as long as we do that, especially the blade, as long as we go back with the OEM blade, then our RPM should be correct. The only time our RPMs will be wrong, if we go back with the original blade, is when I'm underpowering the motor, right? If I had a 6 watt motor, a motor that burned 6 watts, and I put in a 4 watt motor with the same blade, it's gonna run slower. That's the only time I'll have a problem with RPM, right? That's the only thing RPM would show me. If I had a 6 watt motor and I use the same blade and I put a 12 watt motor in, it's gonna turn the same RPM,
Yep.
right? Now, the motor's gonna overheat and burn up and die, but the RPM's gonna be the same and the airflow will be right
Yeah.
until that happens.
Yep.
Okay?
Yeah, people are changing those.
Why are you looking at me like that?
Not
You
programming
take out a
Yeah.
6 watt and you put in a 12 watt, and 12 watt's gonna burn itself up?
Yeah,
Yeah.
sure.
Yeah, it will.
Because, it's a good question, right? He's looking at me like I'm crazy, right? Because I've got enough electrical energy, electrical energy is gonna create heat. These are all self-cooled motors, being the airflow,
okay.
he's got it,
I
right?
got
The airflow through it is going to cool to match the electrical heat load, and I'm running half.
I gotta turn off my mechanical brain and turn off.
Yep, mechanically, that motor's just fine.
Or my automotive brain.
It's just
turn off
gonna,
my-
it's just gonna move half as much air as it needs to not overheat, right?
Yeah,
Well,
some people do like.
Now, how long will it run? It'll probably run weeks, months.
Oh, yeah.
Right, you know, it'll run a long time. Is it gonna get are you gonna get your full life out of it? No,
No.
right.
I mean,
But
you
that's-
never know, it could be there till the
that's
end
the
of time.
advantage.
Might be.
It's been that one out of the thousands that were sent out of that factory.
You
But
got the
that's-
black sheep,
that's
the one
the
that actually
advantage.
works.
Yeah, the one that was actually made
Do it.
right.
That's the advantage of the programmable motors like that, though, is you have a fixed fan blade to a fixed motor that you can program to either 1200 RPMs or 2500 RPMs,
Right.
depending on the case
Yeah,
manufacturer
it'll be
or
right.
the case spec, and you'll be correct.
Yeah, but the one
Whereas,
where
like,
programming
we
them.
carried 6 different sized cannonballs on our trucks for these 6 different era
Sure.
cases that we ran into.
Yep.
That's a lot of truck stock motors where we could have had one.
Yeah.
And that's the missing piece. You have to program it, but that's why that is a, in my opinion, better motor or better setup, because it's more versatile but covers the same range of problems.
There are a couple of different sizes of those.
Should we have
Yeah.
the programmers little stick on our trucks like everybody?
So it depends on which motor you're gonna carry on your truck,
Yeah.
right? You know, it's a valid point to talk about what he just said. In the old days, every technician carried cannonball fan motors. You know, a 3, 4, 6, and a 9 were pretty much standard, and then maybe you'd have a few 12s floating around, right? But that covers 95% of your cases, right? That's just not true today because they're inefficient, right? When I put this cannonball up here, understand when it says it's burning, remember, these are rated in watts, right? Not horsepower. That's our problem, all right? With an EBM motor sitting over here that's rated at 31 watts, and I've got this guy sitting over here, I don't know what this guy is, 6 watts?
Because
Six-
it's
6
a
watt motor.
small fraction of a horsepower.
How many horsepower is that,
.42.
right?
Nice.
If I don't have energy loss of any type. Oh, this guy is massively inefficient.
Yeah.
Yeah.
It's running about half of what he just said. Because I'm losing at least 50% of it to wasted efficiency. Because it's running I'm pulsing this thing 100%. It's not pulsing, it's constant. Right? Whereas this guy, I'm pulsing. Oh. So that quarter horsepower, or tenth of a horsepower, this guy's getting 20 times, 50 times. This guy's getting it all the time. Right? They're doing the same amount of work. So that means this wattage doesn't mean anything. That's what it means. Right? When I go to these EBMs, all bets are off. This is an insanely inefficient motor, and I'm losing at least half of its power. It's not horsepower, it's heat. Right? That's why I'm going to overheat when I drop the 12 in here
So
on my 6.
Is that, or you probably know, is the 31 on the EBM like the maximum
Yes,
that it puts out?
correct.
Yeah.
Yeah, it's not going to run 30.
If
If you slap your amp meter on that guy and start doing some math, you're going to be like, well, she's only pulling 2.
Yeah, but like if you take it as high as it'll go,
Yeah.
and it runs
That-
consistent like.
that's exactly right.
It would run 31.
All right, that's exactly right. So the same thing, if I put my 12 in place of this 6 with the same blade, it's going to pull 6.
Yep.
Right? And, well, actually, it's going to burn the same amount of horsepower since it's such an inefficient motor. It's probably actually going to pull 8
Those are just the one.
to do the same work.
We need a AC 5411E, a 4-watt cannonball motor, a 408E, and 10 and a 12 for the EBM. That would cover all the motors.
Look
with
at that.
CIs. 411E.
Yeah.
That'll cover every single motor we ever need.
That,
Walk-in
alright,
case.
those are there, come in clutch for like 90% of the.
That's why I'm throwing it up here, right? You know, we call this the rescue motor. there's a company now who carries the name Rescue, right, that makes these things. Yeah, what in the world's going on here? Watts are 4 to 25.
Yeah, right.
Think that pretty much covers a refrigerated case.
Yep,
Uh,
can confirm.
my RPM is 1515 to 1725. Pretty much covers just about everything we do, right?
There's some small stuff in there.
Except for zeros.
And there's lots of different versions of this.
13 or 11, no, it's 11.
Now-
They're 9.
Now, this is an important piece that is a really gray area for a lot of folks. Try to clear this up a little bit. Direction, no, you can't read it. This one says CW. What does that mean?
Clockwise.
Okay.
On shaft end, maybe?
Shaft
No,
under lead.
no,
Or lead
no.
in?
So I have seen,
That's where I'm going.
it varies, and it'll say OSE. Is that on shaft end or on,
Opposite
Nobody
shaft
knows.
end.
or is it opposite shaft end?
That's why I have.
That's why I want to talk about it.
Alright.
So
Plug it in, see which way it spins.
there's only two directions a motor can turn. Agreed?
Yep.
Clockwise or counterclockwise?
Yep.
Only two directions. But there's two ways I can look at it. One is from the shaft, one is from the back of the motor.
Always look at it from the shaft.
And when this says CW, this cannonball, is this from the shaft or the back?
You gotta always think it's leading.
With those,
You always have to think what?
Lead in.
specifically with that Fasco motor, it's from where you're reading it.
That's what I'm saying, lead in, like where.
But that's just a Fasco-ism. That's just that manufacturer.
Alright, so Ian just laid it out. It is up to the manufacturer to decide that. There is no standard. Well, that's,
My foot down, there should be a standard.
that's,
Plug it in.
okay? But that is reality, alright? So when I go to replace this motor, and I go to the parts store, I'm gonna tell the guy, this is clockwise, looking at it from the back.
Yep.
Alright, that's what I'm gonna tell him,
Clockwise lead end.
alright? And he's got a whole list of every motor manufacturer that he sells and which way they look at it.
Yep.
Because it does vary, there is no standard.
Are they smart enough to do that still?
Yes. Well, the computer system is.
Their computer system.
Not if-
Alright, so that's the way it was for years and years and years. Now that is changing to make things simpler,
Thank you, Rescue.
and it may have overcomplicated things a little bit. But if we look down on this one, rotation is,
Clockwise opposite shaft end.
Whoa, whoa,
damn!
whoa. Damn, so that's why I'm like.
So you're
we were
saying
like,
that
oh,
I
they're
know
always
motor
backwards, cause it's on shaft.
So there's a bunch of different letters that you're gonna start seeing now after CW or CCW, you know, counterclockwise, right? You're gonna start seeing, as everybody in here except Ian just learned, O is opposite, all right? That's, if you see the O, it means opposite. Then I've gotta figure out what the other letters are. If I don't see the O, that means from that, whatever it's telling me,
Yep.
right? So this one is giving me shaft in, SE is what it's saying. So that means it's always gonna designate shaft in. If there's no O, that's from the shaft end.
Yep.
Okay? If I have an O, that means back, all right? Great, shaft is not too bad. We're gonna leave the world of shaft, and you could have P for pulley. All right, even if the motor has nothing to do with a pulley. That means shaft,
Yep.
but you'll see a P.
Yep.
There's gonna be 20 of these, right? Every manufacturer can come up with their own version of this, right? They may designate the end instead of shaft, right? And we'll see plate, P for plate, PL, right? T for tag.
So,
Okay.
are we positive that that's clockwise, opposite shaft end? Or
Yes.
is that clockwise on stator end?
It is shaft.
The stator's a circle.
Huh?
With US Motor specific,
Yeah.
that is clockwise opposite shaft end.
Okay.
And the reason why I put this one up here is because US Motors is one of our most common. We
Yep.
use this a great deal.
Every
Okay?
single spot.
You do need to learn the ones that you're gonna carry, what their designation is, so you can keep it straight.
Yep.
There is no standard, and I am sorry for that. Proper stuff. This is a picture, perfect example, walked into a store, did not have to look hard for this picture at all, right? If we look at this, if we look at these shelves,
Holy heebie-jeebies.
yeah, I'm outside of I've crossed my load limit, right?
Only
The
by-
top
only
shelf
by
looks like
five.
it might be okay, but that bottom shelf definitely looks like it needs to go down, or it's not even supposed to be there.
Well,
All
it's
right,
always-
so check this out too. This is a merchandiser that's not approved by the case manufacturer.
Yep.
right? It's a container that my associates can stock, set in the case, open, and walk away.
Yeah, and they can
Right?
pull it
Pretty-
pretty easily when
it's
they
pretty
come
cool.
back to them.
Except for this front piece they unload, they pop down. Yeah, that's my air return, guys.
Yeah.
Is that okay?
No.
Yeah. I mean, it's everything we're talking about,
Yep.
okay?
Those poor fellows that get that call,
Yeah.
they try to get it all the time.
Won't be buying eggs there.
Well, you can't, you just gotta reach in the back.
Right.
Huh?
Yeah.
Yeah, I'll buy
So-
it. My ex still have to put them on.
So, you know, load limit is a world famous one, and once again, didn't have to look hard for these pictures, I've got thousands, right, and you've seen it too. This concept, this guy was telling me, you know, it was Saturday morning, and he's saying, yeah, they're about to wipe me out, you know, this stuff won't be here in an hour. I shot it with a core temp, right, stacked 2 pieces of hot dogs together and showed him he was at 68 degrees.
Yeah.
Right.
Pre-cooked.
You know, how long you been there? Oh, just, you know, we just put all that in, it'll be gone in an hour.
Yeah.
68 degrees. It's been sitting like that for 2 days, man. It's, you know, it's not even refrigerated, right?
I got your coolers out.
All right, there's my baffles. All right, so and then air infiltration, okay? So let's talk about this for a minute. That air curtain that we were talking about is very fragile. If you smoke one of these cases or look at it with an infrared gun and have someone else walk by the case, you will see that the curtain follows you. Spills out on the sales floor, it goes right behind you. Right? They're very fragile. The air curtain is actually very, very fragile. Now, is that enough to cause a problem? Not really. You know, obviously, we're shopping this thing all the time. But it does disturb it. Just the act of you walking by the case disturbs the airflow. So, my AHU, that's a 6,000 CFM unit. How many grills have I got?
One.
How many supply grills are on this duct pack?
4,
6.
6. Well, if it's a hexagon.
It is a hexagon, you're looking at it.
All right. How many CFM per grill?
I'd say about, if it's
Divide that
6,000.
by-
divide that.
6,000 by 6.
All right. So we're close to 1,000 CFM, 6,000 CFM unit, 6 grills. That's 1,000 CFM. Okay.
Yep.
All right.
That checks out. Just
All right. 1,000 CFM. All right. This duct pack can be 200 feet from my case and wash out that very delicate air curtain. All right. So when we're talking about air infiltration, don't look around close. All right. Look around in the distance. What happens here, and this happens all the time, these giant signs that say produce or fresh meat or something like that, right? We've got chains coming down from, and they're, you know, these giant billboard looking things, blue, you know, whatever. 10-foot chunk of plastic, says 10 feet, right? We can see the thing, it's just slightly moving too, right? Because the fly grill is just pounding it, right?
Yep.
And then they do a remodel and have us take that off and they put something new on the wall instead. Who re-aimed that duct?
Nobody.
Nobody. Now, it's washing out a case it didn't. Right? If we're the unlucky bastards that just changed that case, and we put in a brand new case that doesn't work. Oh, the old one did, this one didn't, what changed? We don't even think, we just moved that sign because we didn't. I didn't, startup guy didn't. All right, I did not get that picture from Mississippi 15 years ago.
that was Palm Harbor.
You're welcome.
Nope.
Yep, that's it. Carrie had donated that picture, but it shows it really well. This is what he ran into. This was a grab and go that had an RTU for the cashier facing.
Oh, I think I remember.
But I'm talking about, you talking about chasing my tail?
How many feet away do you suppose that was?
Oh, it was, so,
Oh, that to, that.
just to give y'all a pictorial, in the front of the store, I've seen a lot of them in the front of the store.
And this wasn't a dehumid, this was just a little 5-ton,
There,
10-ton
all the way
unit.
to there,
Oh, no.
cause I measured 60 paces from that case to underneath that unit.
Did you A squared plus B squared equals C squared?
No.
My point is, it's a significant distance. It's far enough that when you're standing there looking around, you don't see it. You don't feel the air. right? You have to intentionally try to find these ducts that are washing out your cases, right? And you can see this one's washing out bad. Yes, sir.
So Christian's asking, when we run into these types of airflow issues, and air infiltration, how do we go about that with the customer?
Yeah,
Like,
that's-
how do you get the customer on board to fix that?
Yep. So
Part of the case.
So there's, there's a couple different ways, right? The proper process, if we want to follow the process to a T, is we go through the GM, whoever our GC is, and have them approach the customer to hire someone to fix that ductwork, right? Because it's not really our responsibility. That's the proper process. How does it actually play out?
We get a ladder.
Well, the reality is we can do this very easily, right? So if we see the problem and we can coordinate with the store to use their lift if we don't have one there, right? If it's a big project and we do, who cares? Just jump on the dang thing, go up and move it,
Yep.
right?
We'll put it back or a
Right.
plate on
If
it.
it's during store hours, you still have to get approval, even if it's.
So that, like this particular one, this project was long over, right? We've been having problems with this thing
Oh, yeah.
on
that
and
was-
off
that
for a
was the
year.
beer.
It was a long
Everything
time.
in the-
So now we're working with the store manager directly. There is no GC involved in this project in any way. We don't have a crew there. We don't have any equipment there. So the question's gonna come down to the store manager. Do you mind if I use your lift? That's the first question, right? And if the answer is no, then get your AC guy out here and have him move your duct, because I'm not gonna bring a lift out here on warranty service, right? If the answer is yes, can I use it during the day, right? Well, most stores will allow their techs to use lifts during the day. There is no requirement that they use them at night. So once we get into that mode where the project is over and long gone, and we're talking to them as service techs, then it should be very reasonable for them to let us use the lift during the day. If we're doing this as part of a project, they've been told by their construction managers 50 times to 100, no work during the day, whatever. They're gonna hold us to that. We're gonna be on the construction side. We're gonna have to do this at night. Just how it is. Now, if they tell us we got to do this at night, and we tell them it's not even our responsibility to get your guy in here, you may walk in the store and find him at 2 o'clock in the afternoon changing it, right? It's like, what's the difference? Corporate policy, that's what's the difference. Right? Sorry. There's no reason for that, it's just our policy. All right,
Your back's not cooling.
so somebody brought up earlier, how do we measure this? What are we measuring?
Heavy.
I got good news and bad news, right? The good news is the engineered spec how much air I'm supposed to move through these cases. That's good news, right? I can find that in a number of different places. The easiest by far is that parameter sheet that I shared with you guys last week. If you go to the parameter sheet, there is a section that says air velocity, and it's gonna have the manufacturer's airflow requirement. Now that's gonna be, that number for us is cubic feet per minute. All right? CFM, right? I'm telling you this because when you look on the manufacturer's page, you may find the Canadian version and it's meters, right? It's gonna be a totally different number, right? So we're talking about cubic feet per minute. That's how we measure airflow, all right? CFMs. This particular case is gonna be blowing 140. What does that mean? All right, I can take this reading a lot of different places, a lot of different ways. I'm gonna get a lot of different results. So the reason why I'm not gonna walk up to this case and read 140, there's a couple reasons, okay? But I'm not. All right. That 140 is based on using a specific velometer, the Alnor Jr.
All
All right, that's part one. That's a $500 meter that they stopped making about 10 years ago.
They use a 410 on now.
All right. The second thing that gives me that is if you notice there's a piece of sheet metal stuck to the end of this thing. There's some ductwork. All right. It is not the Alnor Jr. by itself. It is a hood that opens. All right. So it's less than 140 because I'm taking more air than fits in this device and I'm forcing it into a smaller space. What the hell? I don't know. That's what they do. That's what they've always done. That's what they're still doing today. So when they're calculating that 140, it is off of this hood on this particular device. If you want to make one of these hoods and match that, I actually have one, all right? I can give it to you, you can measure the distance, you can fold something up that fits your particular thermometer to capture that same amount of air, all right? If you're not using the hood and you're not using the Allenor Junior, you're not going to get 140, it's not going to happen, right?
I'll get one.
The other thing to note here is that 140 is going to be on a perfectly spotless evaporator coil with perfectly spotless honeycomb.
Hey, you gotta keep in mind, they do this in a factory.
Yes, they do.
This
This
ain't
is a
what you have
lab,
to
this is
know
a
in
laboratory.
refrigeration.
This is a laboratory,
They
right?
put nitrogen in this bad boy to pressurize the coil, and,
Yeah, but
quality
are they-
control says, plug it in the wall, yep, fans come on, airflow's good, send it on.
Are they specing that with a, like when they're taking that, are they using it like with a wet evaporator coil, or is it gonna be dry, or what?
I guarantee it's dry.
Wet or dry,
Yeah,
they're gonna, well, it's gonna be condensing water.
well, yeah, I would say like when they're specing these, they're like, are
When
they
they
doing like
engineer.
what Carrie said, they're just plugging it in without?
No, they're running the case, right? So they are running the case in a laboratory environment. They're running it at 75 degrees, 55% humidity. They're putting the shelves on this thing. They are stocking it with bottles of water, letting those bottles of water make core temp, get below 41 degrees, right? And then they're gonna take this reading immediately after defrost. So the coil's clean,
That's what.
right? Is it wet? Yeah, it's probably gonna be wet. Okay? All right, but it's gonna be at 55% the amount of, at 75 degrees, right? Which, by the way, is 54 degrees dew point, right? Okay. So just know that, all right? So we're gonna use that 140 as technicians, as service techs, since I just told you, you're not gonna match that, so what's the point? Well, we're gonna use that as the basis. We're gonna know that that's the most I should have, and that I'm gonna read less. So if I walk up to this case and I stick it on there and I'm reading 200, is that a clue?
Yeah.
Yeah.
Yeah, it's a clue. Somebody's changed the blade and motor, right? Incorrectly. I'm moving more air than I should. What should I read? Probably gonna read 125-ish,
Plus, yeah, plus or minus 20.
right? I mean, realistically, that's what I'm gonna actually measure, right? So if I walk up to this thing and I'm reading 40, that's a clue. I got a problem, right? The other thing I'm gonna do is copy my neighbor. I'm not having problems with this case. It's the same model case. What is it reading? 125. What is this one reading? Right? And I'm gonna use that to help evaluate it. Does that make sense?
Yeah. So, since we all like rules of thumb, the rule of thumb that I was taught was follow the same rule of thumb that you would with electrical, plus or minus 10%, you're probably safe.
Yeah, 10% is reasonable. Okay.
But anything more than that, start asking questions if it doesn't match your neighbor.
Yeah.
If the whole lineup is the exact same, you're probably doing okay. That's not your problem.
Where am I measuring this? So I can use this tool in a lot of different places. It's a thermometer. So it will measure airflow coming out of my supply. It will measure my return. I can actually stick it on the holes in the back wall. I'll see a lot of those readings. But if I'm trying to get that 140, right, if I'm trying to read what it's designed to do, that is going to be on the supply. That's going to be on the honeycomb. All right? Doesn't mean I can't stick it in the return and find a fan that's out. I absolutely will, right? But I'm not going to have anywhere near 140 in the return. Okay?
Correct.
Yeah, same with the back wall. If I'm trying to find my baffle in the back wall, can I use it to see where my pressure's way higher and then where it drops? Yeah, absolutely I will. But it won't be anywhere near that number. That number's meaningless when I'm not in the honeycomb. Okay, does that make sense? Got a little video for you guys.
The question is 116. Why is this case having condensation issues?
All right, we got water in the canopy.
First thing is this ductwork on the bottom.
Our deck
is not
pan. Notice our
installed
deck
correct.
pan is too low. See that
Supposed
gap?
to be level with the bottom of this here.
You guys see
Forces
that?
the air to be sucked through the front to help with
Alright.
the curtain. The second major issue is that fan sucks air in and blows it up the back of this ductwork. I just had them pull on.
Oh, check out the dent.
Because they caved in the ductwork up top here, and if you look down, it's
Surprise!
vacant.
Surprise!
I don't know why it's sweating.
That's awesome.
Talk Talk to you later.
I bet
Who
that's a
did
coin.
you say the end? I don't know what.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.